Okay, so this is work rate time topic that we're going to discuss. There are 10 questions in this worksheet. A few examples are given to explain you basic concepts, and a few expressions are given out here so that you can use them to answer these 10 questions. So I'll quickly review the topic. Yeah. So out here it says if machine A alone. So what I'm going to do is I'm going to explain you. I'm going to review this. You can go through these examples as a you know discussion of my reviewing today. Yeah, when while you're solving the worksheet. Those who are advanced learners, they know the work rate time concept. Go on, solve the questions, then come to this video. Yeah. So hang on. Right. Work rate time. Yeah. Suppose there's a task to be completed by three machines A, B, C. Yeah. We are assuming out here that all the machines are working at a steady rate and at their respective rates. Okay. So a task could be anything. It could be manufacturing, producing, whatever that you can think of. Yeah. Producing oil, manufacturing, computers, whatever, the motherboards, etc. Whatever the task that you can think of. So this A machine can complete a particular task in, let's say, 3 hours. That same task can be completed by machine B in 5 hours. And that same task can be completed by machine C in, let's say, 6 hours. Okay. Now the question is, how much time will they take to complete that same task if they are working together? How much time will they take to complete that same task if they are working together, starting at the same time? All right. So we'll say let X be the number of hours that it takes them together to complete that task, for which A, if he was working alone, the machine A, if it was working alone, would take 3 hours. Machine B, if it was working alone to complete that task, would be taking 5 hours, and so on. So here the concept is that in 3 hours, A can complete a task alone. Then alone it would do in 1 hour 1/3 of the task. B alone would do 1/5 of the task. C alone would do 1/6 of the task. And if they take X hours together, then in 1 hour they would do 1/x of the task. And that's it. If I take 1 hour and if they're working together, then we simply add up the fraction of the job that they would do. And that's it. This expression we solve to get X. Right? So we'll solve it. 1 by X is 1/3 plus 1/5 plus 1 by 6. All right. And if we take the least common multiple of 3, 5, and 6, it is 30. Right. And this 30, I can express it if I want in this fashion also. 3 into 5 into 6, 15, 6 are 90. So this 30 is least common multiple. You could have taken 3 into 5 into 6 also. So the reason I'm taking 3 into 5 into 6, you'll come to know. So 3 goes into 30 10 times, 5 goes 6 times, 6 goes 5 times. So what do we end up getting? We end up getting 21 by 30, which is 7 threes are, I'm sorry, 3 sevens are, and 3 tens are. So that's 1 by X. So therefore the number of hours would be 10 by 7 hours. Therefore X is 10 by 7 hours. Okay. Now the reason I took 3, 5, 6, yeah, that's also a common multiple, right? So we usually do LCM because that's what we are taught in our school. Yeah. So, however, if you take 3, 5, 6, which is the time taken by A, B, and C respectively, then and then work from here to simplify this expression, we'll go on to this one directly. So 3 goes into this. It's a 90 thing. 15, 6 are 90. So 3 would go 30 times, 5 into 6 times. Right. So I'm just writing 5 into 6. This is to explain your expression, one of the expressions given in the worksheet. All right. Then 5 would go, because it's 90, 5 will go 18 times. So 3 into 6 is 18. So I'm writing 3 into 6. And then this one, 6 will go 15 times. Right. 6 will go 15 times. Right. So I'll write it down as 3 into 5. Now, if you see, 5 into 6 is BC plus 3 into 6 is AC plus 3 into 5 is AB. And that upon A into B into C is your 1 by X. So therefore, you can say X is ABC upon AB plus BC plus AC. That's your expression, one of the important expressions, right? But I've rarely seen anyone work it out in this fashion, because usually this is the best way to solve it. Yeah. All right. So, any guess what would it be if there were only two people working? So let's say same task, 3 hours, same task B takes 5 hours. Yeah. And together they would take how much time? So together AB would take X hours. Then how do you find out the expression? Right. So let me rephrase the whole thing. Let's say a particular task is to be completed by machine A and machine B, and again assume they are working at their respective rates and at a steady rate. So A would take alone to complete that task in 3 hours. B would take alone to complete that task in 5 hours. So together they would take how much time? So let's assume they take X hours together to complete the task, right? So in 1 hour, A alone would do one third of the job, or one third of the fraction of the task. B would take one fifth, and therefore, if they're working together, it'll be 1x. And these two we add up, because in 1 hour, if they together can do 1x of the job, that is equivalent to one third plus one fifth. We solve this expression. Yeah. So again, 3 5 are 15. So this time I can take AB, meaning 3 into 5. Yeah. 3 goes into 15 5 times, and 5 goes into 15 3 times. Right. So I got 8 over 15, which is 1 by x. And therefore, x is 15 over 8. And remember, this 8 over 15 is nothing but a plus b upon ab. And that is the expression we finally get, ab upon a plus b. So that's the other expression, which is there in the worksheet. So you can quickly review it whenever you begin working with the worksheet. Yeah, right? Okay. Now the third concept, yeah, is about a1 upon b1 equal to a2 upon b2. So this is a expression for direct relationship. Direct relationship. Right? So let's say that 20 machines can do a particular task in um, uh, do a task of manufacturing 100 tons of something. All right, yeah. Then if there are 10 machines, will it take will it do more than 100 tons or less than? It'll do half of it, right? 50 tons. It'll do less than. If there are 40 machines, right? If 20 machines can do 100 tons in a particular time frame, in that same time frame, right? 10 machines would do 50 tons and 40 machines would do 200 tons. So as you can see, yeah, more the machines, more the job done. Less the number of machines, less the job done. So it's a direct relationship, and we use this or unitary method, whichever you prefer, expression. Okay. Yeah. So when something is proportional directly, for example, A1 is proportional to B1, directly proportional, then we have a constant usually, and that constant's expression is a1 upon b1, and that one we are using to solve this, you know because these ratios will remain constant. That is your k, and hence we use this expression. Now if something is inversely related, right, for example 10 machines can do a particular task in, let's say, 40 hours, right? Then if there are more machines doing that same task is important. Like in the direct relationship, it was the same time was important. So out here, the same inverse relation, same task. All right, task is the same. So 10 machines can do a particular task in 40 hours. 20 machines will do that same task in how many hours? So 20 machines, more the people are there, then it'll take less time, right? Because they all these machines are working at a steady rate, and all their rates are equivalent in this case. All the machines are having a steady rate, and also whatever rate that they're working on is also the same for all the machines. So more the machines, less the time it takes, right? So it'll probably take 20 hours. All right, I've chosen numbers so that I can quickly get the response. So double the machine, half the time. Half the number of machines, double the time. 80 hours for 5 machines. So as you can see, if in direct relationship both were going up and both were going down, machines were going up, the output was going up, and if the machines were less, the output was less. Inverse relationship, machines are going up, the time frame or the time frame is going down. All right, the time frame is going down, right? Machines, more machines, less time, less machines, more time. So out here we could say that A1, yeah, is inversely proportional to B1, or vice versa. B1 is inversely proportional to B1. So inverse meaning 1 by B1, right? Direct meaning this one. So therefore, A1 into B1, right? So we have to equate this, right? So when we equate this, this is how it works, is equal to constant upon B1. Therefore, this constant is A1 B1 equal to K, which is equal to A2 B2. And that's how we get the relationship A2 B2 is equal to A1 B1, or vice versa. A1 B1 is equal to A2 B2. And this expression we get, yeah, you can write it down this way also, not a big deal, right? This relationship is inversely related. So this expression we use whenever there's something which is inverse. Understood? Yeah. And then there's this third expression. The third expression considers, 20 machines and takes, let's say, 40 hours to manufacture 100 tons. Then 15 machines would take how much time to manufacture 500 tons? Let's put it that way. So when three things are given, how do we solve it? All right. So one expression I have already given, you can use that and it becomes your entire job becomes so easy to solve. But the explanation part is that 20 machines, 40 hours for 100 tons. So what we do is we'll kind of ignore this for the time being, 40 hours, right? And we'll say that 20 machines in 40 hours can do 100 tons, right? So we'll rewrite it, 20 machines, 40 hours, 100 tons. So we are keeping the time constant. So 15 machines in those 40 hours would do how many tons? Correct. If you're finding out this, right, then we use that as constant. So 20 machines, 40 hours, 100 tons. 15 machines in those 40 hours, right, would do how many tons? Correct? Yes or no? Okay. So 15 machines in that same time would do less number of, right? Less number of, the output would be less machines, same time, right? Less machines. So less output. So hence we can use the A1 B1 concept, direct relationship. You need to figure out that this is the direct relationship. Less machines, less output. More machines, more output if the time is constant. Correct? So out here, you have 20 over 100 is equal to 15 over, we need to find out. So that is B2. So B2 is equal to 1500 over 20. So that is 75 tons. And now we use this response as a second expression. 20 machines, 40 hours, 100 tons, 15 machines, yeah. And this 15 machines was 40 hours, right? 75 tons, correct? Yes. So now we have to answer this question. 15 machines right? We know 40 hours would do 75 tons, right? So those same 15 machines would take how much time for 500 tons, right? So 15 machines can do 75 tons in 40 hours. So that's same. Now the constant is machines. So 15 machines, same number of machines for 500 tons would take how much time? So this time the machine is constant. Now you got to figure out if the same machine can do 75 tons in 40 hours, that same machine can do 500 tons in how many hours? So more tons, more output, more time, right? Because the machine is the same. All right, same machine takes 75 tons, take 40 hours for 75 tons, and same machine will take more time for 500 tons, right? So it's a direct relationship again. So again, we use A1 upon B1 is equal to A2 upon B2. Yeah, therefore, what we get is 40. This time, the relationship is between time and tons, the job done. So 40 upon 75 is equal to how much? So A2 upon 500. Therefore, A2 is equal to, that is the time taken. Yeah, correct. Time taken is 40 into 500 upon 75. So that is 5, 25, you can say 20 the, 25 3 the. So the answer is 800 upon 3 hours, right? 800 over 3 hours is your final answer. So you can actually solve this quickly because I'm explaining it. It takes time because I'm writing it. It takes time. Your rough sheet, you'll probably solve it in 1 minute. Okay. Now, even better is the relationship out here. Okay. So, what is the relationship? The relationship is, let me just memorize this question 20, 40, 100, 15. So, I'll just go back and forth. Hang on a minute. 20 machines, 40 hours, 100 tons. 15 machines, how much time for 500 tons? Correct. Right. Okay. So now if you were to use the expression, now memorize the answer, it was 800 by 3 hours. Now if you were to use the expression, like if you consider the relationship out here between machines and time, right? Machines and time. So more machines, if the task is constant, more machines, less time. Correct? More machines, less time. Less machines, more time. Then we know that these are inversely proportional. So we can say machines and time. So for time, we'll put days. Yeah, day one. They're inversely proportional. And machines with tons. So more machines, more output. If the time is constant, more machines, more output. And in that same time, less number of machines, less output. Right? Correct? So then the relationship is directly related. And hence we can say the task or the job done, the output is the job done. So this is your relationship expression. This is how you get it. Right? And this expression, if we use out here, simply understand M1, day 2, meaning time 2, meaning D2, and this is the job, J2. Are you with me? Yeah. All right. So we can use this expression 20 into the time taken. So D1 is days. So time, D remember days. So time. Okay. Right. So that will be 40 and job is 100 is equal to 15 M2. D2 is we need to find out upon job 2, so 500. And that's it. We solve this expression. 1010 cancels with two zeros. We got 8 into 500 over 15. 5 threes are right and 5 hundreds are, and that is 800 by 3. And your job becomes very easy using this expression. How did we derive this expression? I told you days and machines are inversely related, and machines and output are directly related, and that's how I got this expression. And that's it. The review is done. We can move on to the questions now. Yeah. Right. So as you can see, this worksheet, I've given an example, explained you whatever I did right now, but different numericals, and these are all the relationships. M1 D1 upon J1, M2 D2 upon J2. Yeah, machines, jobs, days. Let's out the question. Find the time taken by machine A and B to complete a task, right? If A alone can complete in 5 days and B alone can complete in 3 days. So this is 1 by X is equal to 1 by 5 plus 1 by 3, correct? And that is easy. You can simply use AB upon A plus B. Yeah. So you can say X is 15 upon 8 days. Second one. Find the time taken by machine A to complete a task if B alone takes 4 days and both together take 3 days to complete the same task. Right. So 1 by X is 1 by A plus 1 by B. Remember this. Or X is AB upon A plus B. Correct. So out here, we'll have to use this expression. Or you can use this also. It's up to you. Yeah. So let's use both of them to get to the answer. Yeah. So 1 by X. X is what? 3 days. 1 by A is what we need to find out. B is what? 4 days. So therefore 1 by A is equal to 1/3 minus 1/4. So 1 by A is equal to 4 minus 3. Yeah, that is 1 by 12. So therefore we know that A is 12. And if you were to use the expression X is equal to AB upon A plus B, then X is 3. A is what we need to find out. B is 4 and A plus 4. So therefore we got 3A plus 12 is equal to 4A. So 12 is equal to A. All right. Third one. Find the time taken by machine A, B, C to complete a task. If A alone can do 4 days, B alone 6 days, and C alone can complete it in 8 days. So that is 1 by X is equal to 1 by 4 plus 1 by 6 plus 1 by 8. Yeah. So again, we just solve this. I'm solving it up. Yeah. So we got, yeah, again, we'll use the formula as well. So the formula is X is equal to ABC. And remember, it's not A plus B plus C, it's AB plus AC plus BC. Okay. So that's 4 into 6 into 8. And then it is 4 6 are 24, 4 8s are 32, 6 8s are 48. Yeah. So that is X is equal to 4 into 6 into 8 upon 80 and 104. So we have multiple 4 2s are 4 6 are, right? And 4 goes, right? And then we have 2 4s are 2 13s are. Therefore, the answer is 24 over 13, correct? That many days. So now we'll use this expression itself. So the expression is 468. So 468, the LCM will be 120. Least count multiple. It could be lesser also. I'm just taking 120 because I can see 120 the multiple of 4, 6, and 8. So 4 goes into 120 30 times. 6 goes into 120 20 times. And 8 goes into 120 15 times. So 1 by X is equal to 30, 20, 50, 65. So we have 5 13s and 5 24s. So X is 24 by 30. Correct? Same answer. But this was faster. This was, so like I said, people hardly use this expression. I mean, yeah. Anyway, now how many times in your life you would have probably worked on work time? Just once in your lifetime, and you probably hated it because in school we never understood work time. Hmm. Yeah. Fourth one. Machine A can complete filling 80 bottles in 5 minutes. Machine B can take how long will machine B take to complete 120 bottles, assuming both machines work at the same rate? Right. So if they both are working at the same rate, right, the differentiation of A and B becomes useless because we're already assuming they're working at steady rates, right? And now their respective rates are also the same, assuming that both machines work at the same rate. Out here, the same rate is different from steady rate. Okay, steady rate means they're not speeding up or they're not reducing the speed. Okay, if machine A is working, it's working constantly at the same rate, and machine B is working constantly at a different rate. Usually that's the case, but in this question, machine B is also working constantly at the same rate as machine A. So there's no differentiating factor out here. So you might as well solve it as a unitary method that if a particular machine completes 80 bottles in 5 minutes, then a similar machine or the same machine, you could say, would do 120 bottles in how much time, right? So if the machine is the same and you have given them more tasks to do, then it'll take more time. So you can simply use that A1 upon B1 expression and solve the question. A1 upon B1 is equal to A2 upon B2. Use unitary method if you like, that's faster. So 80 upon 5 is equal to 120 upon B2. Therefore, B2 is, sorry for the space, B2 is 5 into 120 upon 80. 43s are, 42s are, sorry, 43s are, and that's it, 15 by 2 minutes. That's your answer. So now the question is, we couldn't really use any of the expressions. Only after understanding the question, we figured out that, oh, we can use A1, B1 by A2, B2. Correct. Anyway, fifth one. So now that last expression comes in play, so I'll probably utilize this space out here. Yeah. So what we have, 5 machines. So I'll put M for machines, right? 1200 toys, T for toys, and 50 minutes, right? I don't want to confuse that. All right. So this is toys. So don't confuse it to be time. Okay. Right. So 5 machines can manufacture 12 toys in 50 minutes. How long will it take? Three machines to manufacture 1,000 toys, assuming that all machines work at the same rate. So now all of them are uniformly are working at a constant rate and they all have the same rate. Then we use that machines and toys. More the machines, if the time is remaining constant, then in the same time, more machines will manufacture more toys, right? 5 machines can do 1,200 toys, so 10 machines would have done 2,400, right? 2 machines would have done less than 1,200, right? If the time was the same, less number of machines, less output. So therefore, we know that we can use this case of M1, yeah, D1 upon J1. And if you consider machines with minutes and if you keep the output to be constant, 5 machines have the particular output in 50 minutes, right? That same output by 3 machines will take longer, right? Less number of machines for the same output will take longer. So therefore we have this relationship. Yeah. So I'll solve it in both the manners. I'll solve it in this fashion also, and I'll show it. I'll solve it the other way also. So we have 5, 50 for the this is time, day is time. Okay, 5 machines, and the job is 1,200. Then 3 machines will take how much time? So this is D2, you can say, upon 1,000 toys. Yeah. So therefore D2 is 5 into 50 into 1,000 upon 1,200 into 3. Correct? Yeah. So these two zeros goes with these two zeros. And then we have 12. So we have 2 25s, 2 6s, 2 5s, 2 threes are. So the answer is 525, 5. So 625 upon 9 minutes. And we'll get the same answer. Yeah, we'll get the same answer using the other expression. Okay. So let me delete this. Yeah. So just remember 625 by 9 minutes is what we got. Okay. So we have 5 machines, 1200 toys, 50 minutes, right? 3 machines, 1000 toys, how much time? So we say 5 machines, yeah, can do 1200 toys in 50 minutes. Okay. So we say 1200 toys in 50 minutes. Then 3 machines can do 1200 toys in how much time? So we ignore this part. Yeah. And we solve 5 machines, 50 minutes for a particular task. 3 machines for the same task will take more time, right? Correct. If the task is constant, then 5 machines will take 50 minutes. 3 machines, less number of machines, will take more time. So this is the important part. You need to figure out the relationship. Correct. Accordingly, you can apply the A1 B1 concept, whether you use A1 B1 equal to A to B2 or A1 upon B1 equal to A to B2. So this one is inversely related, right? A1 B1 equal to A to B2. So therefore, see, the shortcut is 5 into 50 by 3, but I don't want to get there. I just want to, 5 into 50 is equal to 3 into B2, right? So that's 250 by 3 is B2. What is B2? B2 was the time taken, 250 by 3 minutes. So now we know that 3 machines can do 1200 toys in 250 by 3 minutes. Correct? So those 3 machines will do 1000 toys in how much time? Right? So this time the machines are constantly ignore it. So if the machine is the same or the number of machines are the same, and the task is it takes 1200, it manufactures 1200 toys in 250 by 3 minutes. So 1000 toys, that same number of those same number of machines or the same machine, however you want to do it. Yeah, whether you want to consider it as same number of machines or whether you want to consider it as one machine, it just doesn't matter. So for simplicity, I'll just use it as same machine. Same machine takes 250 by 3 minutes for 1200 toys. How much time will it take for less number of toys? So if the same machine is to be deployed and for less number of toys, it'll take less time. And if it was more machines, it would have taken, I mean, sorry, if the output was more, it would take more time. Correct. So it is directly related. You can use your unitary method. Yeah. Like you can do 1000 into 250 by 3 upon 1200, or you can use this one. Correct. So A1 is 1200, B1 is 250 by 3 is equal to A2 is 1000, and B2 is what we need to find out. So B2 is equal to 1000 into 250 by 3, yeah, upon 1200. So 20 goes with these two zeros. So we got 2500 by 36, but we'll simplify it further. So this is 2 times 5 and 2 times 6, then 2 times 3 and 2 times 125. So we got the same answer, 625 by 9. But clearly, as you can see, this is complicated. And to avoid this complication, we have that expression. So please use that whenever you come across a question like this. And then another example where this expression will come in play. Okay. Question 6. Together, B and C can produce 80 tons of synthetic oil in how many weeks if Machine B alone can produce 40 tons. So B, 40 tons in 4 weeks. Machine C produces 60 tons in 3 weeks, right? So together, B and C can produce 80 tons of synthetic oil in how many weeks? Now, just because you've learned how to, you've learned these four expressions, does not mean you have to use it blindly. So do not try to plug in expressions just because there are numbers of numericals around. Understand the question. Yeah. So that's why you need to practice a lot, right? So if you practice enough, you'll get used to these type of questions. You'll be able to simplify the questions given. All right. So the question is together they'll take how much time? So what we do is 40 tons in 4 weeks, 60 tons in 3 weeks. So together how much? So we can't simply do 7 weeks, 100 tons. That's incorrect. Yeah. So what we do is there are two ways to solve this. Method one, they both are the same things, but calculation, it depends on how comfortable you are with things, right? So if we consider 12 weeks together, let's say there are 12 weeks. So then in 12 weeks, B would have done three times the amount of job, like 120 tons, more time, more output. And this one in 12 weeks is four times, so 240 tons. And therefore, we can say in 12 weeks together, they would have done 360 tons. So for 80 tons, how much? Right? 360 tons, 12 weeks. So together, 80 tons, they would have done it in how much time? Correct. So that is 80. Sorry for my handwriting. So I'll just continue the expression out here. 12 weeks, 360 tons together. So 80 tons, how much time together? So A1 upon B1, right? So I'm just saying it's directly related. So I'm just going to do 12 upon 360 is equal to A2 upon 80, right? So A2 is 80 into 12 by 360. 0, 0 goes, 4 twos are, 4 nines are, 3 threes are, 3 fours are, 8 by 3. So the answer is 8 by 3 weeks. And the other way is simply 40 tons in 4 weeks. So 10 tons in 1 week, correct? 60 tons in 3 weeks. So we know 20 tons in 1 week because in 1 week they'll do one third of the job, right? So one third of 60 is 20. In 1 week it'll be one fourth out here. So one fourth of 40 is 10. So we know together in 1 week they do 10 plus 20, 30 tons. So for 80 tons, it's how much? That was your method two basically. Yeah, that was your method two, right? So 1 week 30 tons, 80 tons, how much? So A1 is 1, B1 is 30, A2 is what we need to find out, B2 is 80. Therefore, A2 is 80 by 30. That's 8 by 3. Same answer. Got it? Yeah. So learn, understand, and move on. Seventh one. Right. So now I've intentionally given you the seventh one so that you realize that the expression doesn't work always. That third expression. So we'll use the third expression M1 D1 upon J1 is equal to M2 D2 upon J2. The 50 ants, 50 hours, 50 meters, 5 ants, how much time for 5 meters? So read the question. Yeah. 50, 50 goes, 5, 5 goes. So you get 50 hours. How much time? 5 ants take to crawl 5 meters. They take 50 hours. That's incorrect. Why is it incorrect? Understand the question. 50 ants can crawl 50 meters in 50 hours. So imagine all of these 50 ants are on an escalator, yeah, standing next to each other. So they're tiny little creatures, right? So on an escalator, you can have 50 all in a straight line, correct? Yeah. So imagine the speed of the escalator is their speed. So all of them are moving ahead, right? But the escalator is moving so slow that it is taking 50 hours to complete 50 meters, because we are assuming that they crawl at the same speed and they all have to crawl the same path, correct? Or you can imagine, yeah, that the starting point, yeah, we consider 50 ants like this, right? And this is the starting point. All right. So first one, so they all are going to in a straight line. So this one, by the time the starting point, it starts from here, from the starting point, correct? The time is calculated because they're going at the same speed and they're going to crawl on the same path, right? Yeah. Each ant will do 50 meters in 50 hours. Each ant. Can't understand this. Ant one will complete 50 meters. So let's say, yeah, ants, 50 of them, A50, A1, starting point. Yeah. And this is your 50 meters, right? This distance is 50 meters. And the time taken is 50 hours, correct? So A1 starts from here. It'll take 50 hours alone. Then A2 starts from here. It'll take 50 hours to reach complete 50 meters, right? So each ant is taking 50 hours for 5 meters, 50 meters, right? Now, so 5 ants doesn't matter now. Again, whatever is for one ant will be for 5 ants also. So how much time will the ants take for 5 meters? So if the same ant has to cover less distance, it'll take less time, correct? So A1, B1, direct relationship, right? So we have A1 50 upon B1 50 is equal to A2, which is 5 upon B2 is what we need to find out. 50 goes, B2 is 5. So it takes 5 hours. Out here it shows 50 hours. So why that discrepancy? Is because um, their individual output is not considered out here. That's one explanation I can give. Yeah. But let's not get into technicalities, right? When the machines were working, each individual output was added up in that time frame, right? Out here we can't add, okay, uh 5 ants, right? So the individual time we will not consider, right? So the first ant for 5 meters, right? First ant for 5 meters takes 5 hours, right? The answer is coming up to 5 hours, right? Out here, the answer is coming to B2 is 5 hours, right? So that's for one ant, or for all 5 ants would take 5 hours. So we're not individually adding up each ant's time and making it 25 hours. Even then, it is incorrect because this discrepancy is 50 hours. If you were to individually add up the output of each and add them up, even then we are not getting the right answer. But you got to understand, reason out, right? 5 ants to call 5 meters will not be 50 hours. It will be 5 hours. Okay. I hope you understood this. Let's move on to question 8. Okay. So a swimming pool is to be filled up using pumps. Yeah. And if you read the question, pump A can fill it up in 8 hours, pump B can fill it up in 12 hours, and there's a third, let's call it C, which can fill it up in, which cannot fill it up. If you read carefully, it can empty the same pool in 50 hours. So while A and B are filling it up, C is emptying it, right? So how much A takes to fill up an empty pool? It takes 8 hours. How much B takes to fill up an empty pool? It takes 12 hours. How much C takes to uh, empty a filled up pool? It takes 15 hours. So A and B are actually filling up the pool. C is emptying the pool, right? Now the tricky part is that suppose that 15 hours was actually 5 hours or 2 hours or something, that together A and B's whatever X hours, and this C was lesser than X, then the pool would never fill up. So I intentionally took more time so that the pool fills up. Okay, rewind it and hear me again if you want to. I'm just trying to tell you that if the time taken together, yeah, was let's say X hours, and that X was greater than whatever the time. Suppose that I taken 2 hours out here. Suppose I taken 2 hours, right? So to fill up, it takes more time than to empty. Then the pool would never fill up. Okay, right? So that's what I was trying to explain you. But let's solve the question. So this is a very simple question. Let X be the time taken by them to fill up the pool. So in 1 hour, 1x of the job is done, where 1/8 plus 1/12 is the fraction of the job done by A alone, B alone. Together we'll add them up, right? And C in 1 hour does 1/15th of its job, whatever the fraction it does, but it have to subtract it because it's emptying the pool. And so we can use the LCM and solve this. 120, 8 15s are, 12 10s are, 15 8s are. So minus it. Okay. So that's 17 over 120. Therefore, the answer is 120 over 17 hours. Got it? So use a number like 2 hours and you'll see what I'm trying to tell you. Okay. If you use 2 hours, I believe that it will never fill up. Okay. Ninth one. 10 ATMs can dispense 10,000 rupees in 5 seconds. How long would it take the same machine to dispense 40,000 rupees, assuming that all bills, meaning all notes, are of the same denomination? Correct? Right. So this is what I need to assume, that there are no notes like, the real situation is you'll get 500 rupee notes, 100 rupee notes, right? Correct. Or 200 rupee notes. But I'm assuming that all the denomination is same, right? So that this question makes sense to solve it in the concept that I've taught you. So 10 machines, right? 10,000 rupees is the job, so it will come down, yeah, and does it in 5 seconds. So how long will it take? Same machine. So I'm not saying machines. Remember, it's same machine, single machine for 40,000 rupees. How long will it take? Right. So D2 is what we need to find out. Therefore, D2 is 40,000 into 50, that's 10 into 5 upon 10,000. So the four zeros cancel out. So it is 250 seconds. Sorry, 200 seconds. All right. And the last question, 10th one. Okay. Benjamin could type 16 words in 1 minute per minute, which was too slow for his work profile. Hence, his manager asked him to take typing lessons to increase his speed to work efficiently. If after taking the typing lessons, Benjamin could now type 5 words less than thrice his earlier speed. So thrice his earlier speed and 5 words less. So that is 43 words per minute, right? 5 words less than thrice his earlier speed. Benjamin could now type 5 words less than thrice his earlier speed. So his earlier speed was 16 words per minute, right? 5 words less than thrice his earlier speed. So 16 3 the 48. Thrice and 5 words less. So 43 words per minute. Okay, understood this part? Yeah. Anyway, so the question is, if after taking the typing 5 words less, then how long would it take him to type 150 words? So we know that now, how long would it take him now to type 150 words? So 43 words per minute, 250 words, how much time, right? So A1, so you have more words, it'll take more time, right? So 43 over 1 is equal to 250 upon B2. So B2 is 250 by 43. And don't forget the unit. Unit is minutes. Right? So many people get confused out here. It's minutes. So that's why you need to write it properly, words, or use shortcuts. And that's it. That's your answer. Thank you for watching. Yeah. Thanks for staying. And I think that's it. I don't think so. There will be more topics I would have to discuss, but whatever it is, you can email me or comment, put it in comments. Yeah, email is better because I hardly see the comments. All right, but yeah, you can comment also. I'll get notification. So you can, if you want any net part A topic should be discussed, just let me know. Any aptitude math topics, I'll try and create content for that. Thanks.